Hey guys, welcome back to another Prefect Live. Today we're here with the man, the myth, the legend, Mr. Kevin Kho.
And his name is John C.
There he is. What's up, Kevin?
Thank you for the intro. It's very fitting. So hey everyone. Um, so today what we'll be doing is a machine learning grid search over Dask using Prefect. No need, and this will be interactive with Chris. No need for any machine learning knowledge beforehand, or we'll go over it together.
Because I
So
certainly don't have any.
really, I
No,
think you do.
yeah, I
You
have a
do.
little. Yeah, we'll
Yeah,
figure it
yeah.
out.
So what we're gonna do is we're gonna basically just try a bunch of machine learning models simultaneously and just see which one is the best fit, right? Um, a lot of times, like you want to strike this balance here, where your model is just fitting perfectly, not too aggressive, not too relaxed, right? And in order to get here, you have to tweak some parameters, hyperparameters of your model, right? To dictate how aggressive it's going to be. So frequently what's going to happen is you're going to test a lot of these combinations until you converge at what looked like the best ones, right? And the second thing we have to talk about is distributed machine learning. So this is from the Dask documentation. Distributed machine learning, there's two cases, right? Number one is like your data is too big, it doesn't fit on one machine. So you have to do machine learning on everything simultaneously. And while you're training in those iterations, like they're all like communicating with each other to kind of aggregate those metrics and train that model, right? The other form is compute bound, where like you can spin up like you have a small data set, but you want to try like maybe hundreds of models on it. And if you run it sequentially, it would take like 2 days, 3 days, that kind of thing. So instead, what we're going to do is we're going to use a Dask cluster, have hundreds of these. We're not going to do hundreds here, but you could have hundreds of those small jobs, and you can run them all simultaneously and then spin down your Dask cluster, right?
I
And
think
that's
this
what we're
slide
going to.
is perfect for anyone who's ever had to explain machine learning constraints to like a boss or something like that. It's like, well, why can't we run it on the one server that we have, or why can't we run it on this cluster that is compute intensive, for example? So I've never seen this before. I like this a lot.
Yeah, and if you are here, you don't need Dask. Like I mean, you can use Dask, but you don't need it for sure. And if you are here, things are really hard, honestly. Things are a bit harder. Um, yeah. So what we're gonna do is we're gonna create a lot of different models, run them all simultaneously, aggregate those metrics, and look at them in the Prefect UI. So the the goal here, I don't know if we're gonna reach this today. It's we may have some technical difficulties when it comes to the scaling out with Dask, we'll see. But we're gonna have a prefect flow with a Dask executor. So this is the cluster, and the Dask executor will have a couple workers, and each of those workers is processing some number of models, and then we get all the results back. So this is the goal today. So with that, let's get started.
Let's
Um,
distribute. Let's go parallel.
well, not quite, not quite. We're just gonna get the basic model first. So what we're just gonna do is I'm gonna first try to use the Titanic data set. Um, what I'm gonna do is download it from Kaggle, right, and put it in my folder.
We love the
So
Titanic data set here.
Wow.
well, we can get this. We're just gonna get this training guy and copy him. So
Mm-hmm.
I may need to log in to pull this guy. Oh no, I'm good. I'm logged in. And then this thing, I'm gonna rename him Titanic, and I'm gonna put him in my working folder. So I'm just gonna copy him, and I have this PrefectLive folder, and I'm gonna slap him in there.
Nice.
and we don't need this anymore. So now we have our Titanic CSV. We should be able to just import him.
What's up in chat, James? James is, I think he's spamming Craigasm for every time we play.
Wow. Wow. Wow.
Okay, so now we have this data set, and for those who are not familiar with this data set, it's a very common starting data set for machine learning. What you do is you are trying to predict who survived the Titanic and who died. I mean, yeah, who survived, who died. It's the same thing, right? You're trying to predict that. No, because it's just the inverse of each other, right?
Exactly.
So we have this, and of course, not everything's gonna be useful here. If you're not familiar with the Titanic, sex and age are very important, right? Because of course the Titanic is sinking. They save all the females. They save all the kids first, and then the males kind of get the short end of the stick, right? So we are going to drop the like this name doesn't help us for machine learning. This passenger ID doesn't help us. So we're gonna drop a couple of columns here, and we will keep only the relevant ones, right? So I'm gonna do df. I want to keep survived, passenger, class, sex, age. This sib sp is like the number of siblings or spouse, I think, that you have, um, so that you're saved like together. The this prch is a parent child. The ticket doesn't give us much information. The fare does, because if your fare is higher, you're richer, and you just have a higher chance of being saved also.
Higher decks, probably. They're probably on higher decks. My theory.
What's dex?
On a boat. Decks, I guess.
Oh,
You know what I mean?
I see
Yeah.
what you're saying. No, no,
Yeah.
no. What I'm saying is like you pay for the lifeboat.
Oh,
No,
right,
that
right,
kind
right,
of
right, right.
that
Yeah.
kind of deal. But yeah, I could see that too. So what you're talking about is cabin, right?
Right,
You
right,
could be
right.
on a higher cabin. Cabin, unfortunately, for this data set is poorly filled, so we can't quite uh, use it. If you want to see what percent of records have it, um, I think you can do dot sna maybe, and then dot sum over df dot shape. Oh no, okay. So 77% of the records of cabin are null. It's not useful
Right.
for machine learning, yeah. And then embarked is, I think there's just 3 values for embarked, like SC and something else, and maybe very few missing records. This is just where they embarked the Titanic, right? So we want to keep these, and that's good. Oh no. Uh, why is the error so hard to read?
I know.
Jesus. I probably just misspelled something. Df.columns. Survived, P class, sex, age. What? I'm not
Huh.
seeing it. Yeah, you
No.
see it?
No, I don't. No, I don't see
No,
it.
I'm not seeing anything. I'm gonna try reading this data set again. Sorry. I'm just lacking an outer bracket. So that's good. We filtered our data set. Still takes some. Oh my god. Okay, still take some massaging. So we want to predict survive, yes or no. This will still take some massaging. Like for example, the sex here, we need to change that to uh, binary encoded 1 or 0, just because machine learning models prefer numbers. So man, I don't. There's a new command. I don't memorize it. If I mess up, we'll just have to look for it. PD sex is factorize sex. I think it's like this. Oh no. Okay. We'll just have to look for it.
These errors are hard to read.
Yeah, I don't know what happened. I
See
think
if see
I
if
think
see
my
if chat can beat you to it. I know they're
yeah,
typing.
chat, can you help? Chat?
Chat. Anyone? Anyone?
Anyone? pd.factorize. That looks.
You
Oh,
just
I need
use
my.
your cat.
Okay. Now back again. Our
Does that work?
sex is
Oh,
good. Yeah.
look at that.
Yeah. Of course. Of course.
Nice
Thank
job,
you.
Kevin
Thank you.
Kho.
Thank you. Thank you. Uh, Next thing we need is this embark, because the embarked is a character right now. We need it in some numeric, but what we're gonna do is there is this function called get dummies. And are you familiar with this?
I'm
By
not
any
familiar with
chance?
Get Dummies.
You're not
No.
familiar. Okay. So what it is I'll just show it to you because it's easier if we just see
Hmm.
it. Basically, if there are three values here, you're gonna end up with three columns. One is the C, and then the other is Q and S, and then the sum of these three columns will be 1.
This is
So now
awesome.
you have three columns, right? So we want this also.
This is really good for like seasonality stuff. For creating columns, I think with like months or weeks or something like that.
Yeah, like day of week. Day of week, you
Yeah.
wanna split
Yeah.
out to something like this, because like
Yeah.
especially like day of week, right? Like if you do like 1 through 7, it's not clear that Sunday is beside Monday, like that kind of
Right.
deal. Yeah,
Right.
exactly. So we're gonna store this, and then we're gonna merge it back to the original data frame later. So now we're gonna just put stuff together. So I will move this up here. We wanna keep that, and then this is good. This is good, and then we want to concatenate them. Well, first we want to drop um, drop the embark column that we're gonna replace in place true. Actually, I won't use it. I don't know if chat has opinions. I can't see chat, but
Hmm.
in place is not. It's gonna be deprecated. It's not good practice. So don't do in place. Um,
I'll ask.
okay, yeah, but I don't know if chat has opinions. And then we can concat. So we'll use the pd.concat. Um, the original data frame, the embark data frame. I think there should be a list. Embark. Okay, and if this all goes well, we are good. Okay, we're good. So we have the CQS. These are the embark. Now the what we have to pay attention to is how many null values there are. Just because not all machine learning models like null values, right? So what we have to do is just check across which ones have nulls. I think we should be good. Or let's see if we can get this command. Df dot.
Chat's opinion of you is very high, Kevin. A lot of positive opinions.
That's that's just our colleagues.
Surprise. Any Metal
So
Gear fans out there? Any Metal Gear fans? Sorry, I'll let you get back to it. I'll stop distracting.
no, it's fine. So only age has null values. So we want to fill this age column. So what we're gonna do is first of all, it's not good practice to just fill it straight up. So first, when you do machine learning, you want to split your data set right into two parts, and then you train on part one, and then you calculate the metrics on part two, right? And this is the train test split, and it's so that uh, you are kind of mimicking that, like, hey, I'm deploying this model in the real world. It hasn't seen that data before. How well does it generalize? So you train on some set of data, but you test it on data that you hold out, right? So when you fill like a missing value like the age, you wanna fill it with the training. Like I'm gonna use the training mean because you don't know like that test mean ahead of time, right? So here's what we're gonna do. We're gonna
Why mean versus median?
mm,
Any opinion there?
no opinion.
Okay,
No
could be
opinion. We can do median. We can do median. We can do
Yeah.
median. Yeah. But okay, so what we're gonna do is df age dot median, and first I need to split, right? So let's see if we can get this import from sklearn. I don't know if okay. We need to find this import from sklearn. Okay, model selection dot train test split, and then we can do. Oh my gosh, these hints. Gosh, that's why you don't use Jupyter. No, just joking. Just joking. Okay, import train test split. And then here we do the train test split on our data frame. And I think it takes like a test size. And this is where we'll say 20%. So 20% is that holdout, right? Now, this returns 4 things. I want to make sure I get the order right. X train, X test, Y train, Y test. You familiar with this?
No, I'm not.
Nothing new. X just like in
Well,
mathematical.
I'm not familiar with this train test split from sklearn.
Oh, okay, but you know
Yeah,
X and Y,
yeah,
right?
Yeah,
Like
yeah.
just mathematical notation. Train test split. We want to get the X train, the Y train, and then X test and Y test, right? So we will do this test first, this split first, and then we're gonna fill in this age variable. Actually, I didn't define Y. I think I'll need to define Y here. X, Y. Okay, so you have to say Y equals df survived. X equals df dot drop survived. Axis equals 1, maybe. And then we do the train test split. This has to take X and Y. And then that I think this should be good. Let's try this. Okay, perfect. That worked.
So this filled your nulls with the median.
No, not yet. So we have to do that. So now we will do our X train dot fill in A X, or first I'll pull that median out. So fill value X train X train age median. I'm sorry, I'm like the slowest typer, I feel. I type
Oh, no
with
way. You're typing very fast. You're coding very fast live.
No. You should bring Dustin here. I want to see that guy with all his keyboards.
Dustin has refused to go on PrefectLive so far.
Oh, okay.
So far, we'll just pressure him to come on. No pressure, Dustin. He's definitely not watching.
And then I'll just do in place equals true here. I think it's faster. Is there? Oh, if there's none, then I'm just gonna straight up X train and X test. So now we have X train and X test, and we're gonna fill them both. And that's it. That's all the prep we need. Good thing we're done with this. I'm gonna put this import up to the top. That felt like a lot, but we have to. And now I'm gonna put this here. And now I'm gonna, same thing. I'm gonna combine this guy here. And now
we're in the upper left quadrant of that chart that you were showing earlier then, right? Because we're doing like a high number of models.
Yes.
And obviously this data set's fairly small for anyone who's used the Titanic data set, right? Well, what is our train like? So it's 80/20. How many rows are in this data set? Do you know?
Yeah, 8,000.
Okay.
It was like 8,000 something earlier. We'll find out. X, we can just do df dot shape. Oh, 890.
Okay, yeah.
This is very there's actually something about this, because I don't know when, I may be wrong now, but like when I tried using like AWS SageMaker's auto ML tool, the limit was 1,000 rows of data.
That must be on the free tier, you would think, right?
No. That of the like full pipeline auto ML, it's like, yeah.
Really?
That's
Wow.
maybe it's higher by now, but it was pretty low
Interesting.
back then. So we have our get data. I restarted my kernel. Just wanted to run everything, make sure it. Oh, I didn't return anything. Return xtrain. I'm just gonna copy this set, and then we do our same thing. We can, and I just want to make sure this works. Perfect. Okay. So now our machine learning model. We're gonna so the most basic like machine learning model for classification is logistic regression. So I think, oh my gosh, I have to find the import. We want logistic regression. Oh my god, I just want, that's not even, I guess that might be it. Okay, so we have logistic regression, and if this all works, we should be able to just then we want to compare our accuracy. I think it's metrics import accuracy score. Okay.
So what are we using? Accuracy?
Accuracy is just a plain percentage, like what percent you got right. Nothing fancy.
Nothing crazy. No R2 here.
No. You, I don't think you can have R2 for classification for
that's a
binary outcome. Yeah.
Yeah.
So now we can fit this model, and it should be, we have these guys, so it should just be a matter of model.fit xtrain, and then we predict, so model.predict on the test data set, and then we call this as ypred, and we want our accuracy score on y test and ypred, and this should print. Oh no, okay. Oh, sorry, okay, ytrain. Okay, so we have a baseline, and we're 77% accurate.
Wow.
77 point. Wow, that's impressive to you.
Yeah.
No, I mean, I don't know what the theoretical ceiling is, but we can definitely do better. So what's nice about scikit-learn is all the models follow this fit predict format. So if I just change this guy, this code will still work, right? Import like this k neighbors classifier, and I'm just gonna replace this line. And if I just run this, oh damn, 66%, right? So went down. But the point is, we have this piece of code that's very reusable, right? So we can just wrap it in a function. So if I say something like a def run model, actually let me cheat a bit and go to my go to my finished code here, just to, no, never mind. we'll swing it. Okay, so we have our
eternity later.
what did that say?
That was a SpongeBob reference. One eternity later. That was a joke, Kevin. Okay, classification. Can we find some funky ones? K-neighbors classifier.
That's not funky. That's very naive, right?
Yeah.
Do you know what this is? What this does?
No.
It just gets basically who are the nearest data points to you? What do they say? What's the
Mhm.
vote? What's the vote that they say? And
Oh,
then
interesting.
that's what you are too, right? That's why it's very bad. That's right. So if we use this get models and we say return return this and return the logistic regression like this.
Mhm.
Logistic regression is actually just linear regression. It's like just drawing the straight line, but in a transform space. So that's very basic. And then we have this, and you take in the model and xtrain. This requires all those guys, the x test, y test. And now what you can do is because you have this, you can say get models is get models, and then for model in models, run model, and then we say model, same thing, yada
We're doing
yada.
them
And
all.
now, yeah, y train,
This is cool.
x test, y test. And now what I'm gonna do is actually I think these need to be created. Okay, so this will work. I just want to print the accuracy score also.
Mhm.
Just so we get some kind of output.
Do you want to print it with the model name too?
Yeah, we'll do that. We'll do. Oh yeah. Good idea. We don't know. I think it will be like model dot. I it's like so buried in there. Let's let's get.
But we're sticking with linear stuff for now. I'm not going to do decision tree or anything like that.
We will. Of course.
Ooh, okay.
Of course.
Okay.
Yeah. There. So you get the. Okay. So good suggestion. And yeah, that's so sexy already, right? But
That's nice. It looks good.
Yeah, but what we're gonna do now is let me think. I think this is good enough, and we can already bring this to Prefect, right? So I'm gonna copy this guy. We're gonna move to VS Code. I screw. Oh, I am in VS Code. I forgot. We're gonna move to a actual my flow, and we're gonna just move everything over. This. We'll move all the imports up. And then you get this, this guy has to go to our flow logic. But what's nice now is all we have to do with Prefect, right, is import from Prefect, import flow task. Is there anything in the chat? I can't see the chat. Is there anything?
We've got Ruchi saying they're going to move to VS Code. And then Anna said she was a slower typer than you. So no questions yet about any of these models are doing this.
Okay, so we get, why is my task? I'm not used to the syntax highlighting, but I feel like this should be like red, you know? But now we can, and then we just get data. We get our these guys. Oh, this is equal to get data. And then models, get models. And then we run each model. So run model dot map, and we will map this models, right? And then the other four guys are these guys, I'm gonna copy them again. These guys are all unmapped.
Mm-hmm.
I don't believe Anna is a slower typer.
Yeah, neither do I.
Whenever there's like a Slack question, it's like bam, like she just types like this huge response so fast. Okay. And then we need to import unmap, and we need to, because this is a task that outputs 4 guys in Prefect, we just need n4 outputs like this. Now, moment of truth. Ideally, everything should just work. cd PrefectLive Python myflow.py. Yeah, so we're good, right? So we have our logistic regression, we have our k-neighbors classifier. And what's nice, right, is that all we did was earlier we had a for loop here, and we replaced the for loop with a map. And now the map syntax is like can handle any number of models that we pass in to this get models, right? So now we can just go ham here, and we can test as many models as possible. So I'm gonna just pull a
Let's
code
go
snippet.
ham.
Yeah,
I would love to go ham.
I need to pull a code snippet. It's gonna be painful to get all the imports right. Okay, I have it. So we are gonna throw in this. We're gonna replace this with this. Yeah, bam. Okay.
Nice.
Where's my sound effects? Where's my sound effects?
This was this was. I feel like this deserves another air horn and probably one of these.
Wow.
Pretty good.
So we have this, and we're good. So now we have six different models. So this is our decision tree. This is our, honestly, like you don't need to know because like this guy tends to perform poorly. And then the random forest, right, which is like multiple decision trees, and we just aggregate the results, right? The concept of a random tree, right? It's like many weak learners make a strong learner.
Yeah.
That's okay.
I love
So we can.
I love thinking about like the example of an actual forest, right? With a random
Yeah.
forest. Like you go one level, you choose a path, you go another level, you choose another path, and you just repeat that over and over. And wow.
Exactly. And so, why did everything seem to have gone up from our our experiment in the notebook?
Yeah, that's really interesting.
I think it's just the randomness associated with the way we split the data, because that's
okay.
we didn't set a seed there. So that could be it. But yeah, so our baseline was 80%, and the random forests are this guy's slightly better, right? Actually, just to confirm, I'm gonna rerun this, and we're probably gonna see like different numbers for everyone. Yeah, we did, just because we didn't set the seed.
Interesting.
It's crazy though how much can change.
What's
but anyway, yeah.
Is it interesting? The two random forests there, are those two random forests?
Yeah, they are. The difference between them is one of them can go deeper.
You're setting different parameters. Yeah. Okay.
So it looks like this added layer of depth didn't yield anything for our model, but that's just again due to randomness. Like now they're different, right? Okay. So what we're gonna do is we're gonna modify this print, and instead we're gonna return. We're gonna actually return it so that we can aggregate the stuff later. So what we're gonna do is model and this should give us this. And then accuracy, which will give us this. So we don't need to print it. Actually, in prefect land, we would use the logger, but whatever. We don't need the logger anymore for this. We're going to return this. And then we need another final task just to aggregate all of the results. And this one will take in a list of results. And we are just going to create a data frame from results. And then return this data frame. And then now we can say experiments. And then maybe here we'll say result is equal to get results. Or I don't even need the result. I'll just say get results experiments. And we can use flow.run. Okay, so I lost the I should here I should just use .head so that we see some kind of output.
Mm-hmm.
I'll print this head if that helps. Nice. So now you have this nice table, right? This random forest is
Crushing
why is
it.
it so this was too high. But anyway, so now today's topic was about, okay, how do we distribute this over Dask? Well, in Prefect, it's so simple, right? All you have to do is get the executor.
By the way, 86% too high, but 77% too low? Question mark, Kevin?
Wow, someone's really paying attention to numbers, whoever that is. Is that you? Is that
It
the
was
chat
me.
question? Or
No,
that's
that
you?
was
Okay,
me.
okay,
That
okay,
was
okay,
me.
okay. Yeah.
Looking
Because
for looking for Goldilocks, just the perfect medium
I mean,
rare.
back to the original slide.
Yeah.
We are probably this 86 is probably here. Probably. I mean, not really. I don't know. There's probably something wrong with that. I mean, I'm just saying that because that's the highest number I've seen.
Yeah.
And then we do local dash executor. And now it's parallelized. Easy, right? The last thing we're going to do is we will use the prefect UI to render this as a table. And in order to do that, all we have to do is create an artifact from prefect. This one I don't do often. I'll need the prefect API.
Yeah, we definitely have not done this on stream yet. Oh wait. Yeah, I don't think we've done this on stream yet.
Okay, I think Laura has.
Well, I think Laura has, not on PrefectLive, I mean.
So I just need to get this guy, the artifact, and I just need to do create markdown artifact. So I'm gonna there's just two things. Number one, we'll do create markdown artifact. We'll pass in this res, and conveniently the data frame already has a 2 markdown, and I think that's it you need to do. So we will run this on the prefect and see what it looks like in the prefect UI. So I'm gonna register this. I'll create a new project for this. So I'll get an error saying this project is not created. So we will create it with this command line. And then we will register it. And now we should see it in the dashboard. I should have my PrefectLive project.
Very nice.
And we have this test. And now we will start an agent. Actually, I'm just going to change environments first to be consistent.
You haven't renamed your team yet, huh? In the UI?
No. I don't know how. I don't know how, right? now we have our agent, and we will run this. And it shouldn't take too long, and then we're gonna see that artifact persisted. Oh man, disaster. It's probably the two markdown that we changed. Or it might be an import environment. Oh man. Well, looks like nothing even ran. Sorry. So we loaded the data from this place, and the agent doesn't have access to that. So we are going to just start the agent inside a place with it, like inside our directory. And then this, I believe this will work now. Otherwise, chat can help out.
We got a good number of viewers in chat today.
Oh, really? What's good?
15.
15?
Yeah. Still.
We're gonna
You've
catch up.
You've kept them hooked.
We're gonna catch up to those ASMR streams with thousands of people.
Yeah, we will. You just need a microphone like this, Kevin.
Can you do the like they tap the microphone like this?
Yeah.
You know?
Yeah. Yes, but I'm not going to.
And here we have our accuracy metrics. Where's my sound effects? This is the...
Wow.
Really, really good stuff. Also,
Is that it?
I'll hit you with a
Bruh.
very nice.
Bruh.
That's actually from I think Left 4 Dead 2.
Oh, okay.
Yeah, I think that's what that's from.
It's better than my conference presentations. Oh yeah, I'll just zoom in just so people can see. So now we have this artifact. Our stretch goal is running it on Dask, and actually, well, there's two ways we can go. We can try to run this on Dask, or we can play around with that search space and make it a lot bigger. Yeah, I don't know what do you want to see.
Well, another cool thing you could do is, because you've got this artifact in here generated from the UI, you could parameterize this. So, for example, let like a analyst, for example, change the depth if you wanted to on in this example on the random forest one, right? You can just make it
Okay. Yeah. That's a good thought. Okay, so we can roll with that. I'll have to go back to Jupyter. I have this another project I'm involved with called Fugue. But that's with Fugue, we have this library called Tune, which is specifically for hyperparameter tuning.
I love it.
So we have from Tune import. I think it's like space rand int grid. Oh no! I thought I just installed it. What? Or it might be Fugue Tune. Okay, that's not it. Let's take a look.
You know, I don't have on here the Jeopardy theme. I really should have had the Jeopardy theme.
No, this is right. What? I have Tune. How come it won't? If this is okay, that's sad. I guess we won't use it. We'll just parameterize. I mean, I can. Maybe I have to restart the kernel. No, I legit. Oh. Okay, now it installed it though, so I don't know what environment this like Jupyter thing is using. I'm gonna restart this. We don't need these guys anymore. They are in our file, and we can hopefully import this tune now. We'll just try. Lovely. Okay, at least it didn't. Okay, so good.
Nice.
So now we have space rand int rand grid. And this space is a generic concept, right? So you can do like space and let me see how. Okay, a equals 1 2, or sorry, grid. I need to say grid. 1 second. Yeah, exactly. So grid 1 2, and b equals grid 2 3, and we should make the, never mind. The list. I need to list this, right? And it made all the combinations, right? So this is what you're saying, right? Can we parameterize depth, right?
Right.
But what we can do is we can define our search space with this syntax, right? So what I'm gonna do is again, we can import I'm gonna just copy this logistic regression import from here, and then we can say we can use this similar thing where we can say space model equals logistic regression. And I think this logistic regression has a parameter called like this. Let's say this penalty, you want to go between L1 L2, so you can say penalty is a grid of L1 L2, right? And then it will make the search space for all these combinations, right? You see where this is going? So now we can create, especially with the random forest guy, we can create a lot of things, right? A lot of combinations. So I'm gonna copy this, and with our random forest guy, I need the import also. So with the random forest guy, I have what I can do is I can choose like, oh, max samples is going to be a random number between 0.8 and 1, and then the max depth, which has to be an integer, is going to be between 3 and 4. And now and then I'm going to sample, because I have a random number here, I'm going to say draw me 4 of these combinations, right? So now I can do this. Bam.
That's cool.
Bam. Sound effects, right? And we have the random samples here and the max depth. So to your point, like, hey, maybe like you can try like these other combinations. So going back to the prefect to this, what I'm gonna do is I'm gonna replace this function that just returns me like a couple of models, and now I can fill this in with space, right? So what it's gonna look like is like what I'm gonna do is like RFC models, and this is the random classifier models, and I'm gonna say 4, and then I'm gonna, like, let's say what other model do I have? Like a decision. Yeah.
SVC, linear regression.
Oh,
SVC sucks, but
the SVC is really bad, but
I think it's used for though when you have. I think SVC is for when you have small data sets.
I've just never seen it do anything. So there's a C, and this is a float. I think the default is 1, but I think it goes greater than 1. So inversely proportional. Okay, what I'm gonna do is for the SVC, we're gonna have another space, right? And this SVC will take in a random number between 1 to like 200, and I think it's called C for this SVC. So we can sample this now, again using the list. So something really cool about this list expression, I just have to import SVC. Oh my gosh, it's like hidden there. Okay, so now something really cool is like I have this and I have this. I can actually add spaces, which is really cool, right? So if I do this and I say RFC, first of all, I'm gonna SVC models, and then the RFC space will be space model is, and then actually I'm just gonna copy this expression. Now I can do the whole space is SVC space plus RFC space, and then I can list my whole space. Bam.
That's awesome.
Round of applause, chat. Round of applause.
Yes.
Okay, so going back to your suggestion, can you
Mhm.
parameterize? What I'm gonna do is make these guys parameters, and then adjust my space based on it, right? So if I go in our the real flow, I have to import this space. So I'm gonna copy. Sorry, I'm gonna copy these guys.
But basically, you've got random grids, and the parameter is going to be how many random grids, right?
Random samples. We don't
Sample.
have a grid. If you have a,
Right.
for example, if you have a grid, like I can attach a grid here. Like let's say, I think this thing has this SVC guy has a, like this kernel, right? I've never used this, but let's say this kernel, and I can say kernel is grid, and I can where'd that go? Why did, oh no, it didn't. I need the SVC. I'm gonna copy this guy. But you have to note that like grid is a multiplier. So for example, if I do this expression, you're gonna find that I think it's gonna be 4 times. We'll see. This and then list. Yeah. So for each of these grid items, we're gonna sample 4 times, right? So yeah, going back, we're gonna replace this guy with our space expression, and this will require some changes. So first, this guy will take in 2 parameters, our SVC models and our random forest models, and then we copy over our space expression for SVC models. SVCs. I have a whole. Yeah, this guy will work. This is good. We probably don't. I don't know if this will work. We'll just try it. It might error out, and then this guy will be RFC models, and that is good. And then we just add our space again, and we okay. Now there's just some additional thing we need to do for first of all is we need to get this simple value for the whole space for each item in the whole space. So x dot simple value for x in whole space here, and the simple value is this is a Python class. The simple value just pops it back out to a normal dictionary, and then we can for each of these models we can we're going to iterate over the space, and we will model params dot pop out the model object, and instantiate it with params, and then we will, like, this will unpack that dictionary. So this will instantiate the model, but then we need to append it here. So it will be models.append, and then we can return models. And what does it not like? Model. Why is it not have? Oh, model. I see. No, I don't see.
Model and models. Oh, model.
This, I'm just wondering why it's red, but I think Pylance is wrong. I think I'm right.
Mm.
Maybe I'll find out I'm wrong later. No. This is good. So now we have this, and then on the prefect side, oh, I seem to have an unclosed something or extra. What? Oh, from. Okay. There we go. There we go. Okay, so we're good. And then we have two parameters. So they're called SVC models and RFC models. I have to import parameter at the top. Yep.
Cliffy D got your got 4 model params, not from. Right when we got it too. Right when you got it.
Cliffy D.
Cliffy D.
Man, you the man, Cliffy D. Okay. So I have two parameters, RFC model. Cliffy D, you should have helped me out in a lot of places earlier. Is Cliffy D is not a prefect employee, right?
No, we've actually got 1, 2, 3, 4 first-time chats from viewers. So, what up, gang? Thanks for joining,
Thank you for joining, gang.
gang. We got to think of what we call prefect chat. Gonna be honest, chat. Kevin and I almost turned this into a Dota 2 stream before. Yeah, if this was going off the rails, we were just gonna talk about Dotes. So, I'm glad we're still talking about prefect.
I'm running out of time here for the hour, so what I won't register. I'll just use flow.run.
Yeah,
and we'll just get stuff working and then end the stream.
that sounds good.
I hope this works, so we can just do Python SVC models. Oh, I need to supply. Why? Okay, SVC parameters, SVC models for RFC models for missing. Oh, it's inside here. Well, it's the same value anyway. It doesn't really matter if I flip them. RFC models. Oh, perfect. We're slowing down because there's so many combinations now.
But this is happening locally in Dask, right?
This is a local Dask executor.
Yeah.
Yes, exactly. Yeah, so you can fan this out to a Dask executor. Same thing if you have one. I could spin one up. We don't have enough time, but for my demos, I will spin one up. The content here will be made, will be largely shaped to be my February demo, so I will get that eventually. Yeah, and then we can end it there. This is just gonna run for a while.
Cool, awesome. Well, Kevin, hopefully you can come back on PrefectLive. This was really interesting, really awesome. Love doing stuff live with you. So thanks for coming on PrefectLive. We'll see you soon.
All right, see you guys. Thank you, everyone.